The Tokenizer and the Lexer story, or a closer look at XML shenanigans. Just a few weeks ago, I mentioned that it is not possible to parse XML with regular expressions. But yesterday, I had a lot of fun doing just that. This is because well-made configuration files do not nest the same element. It is okay to have siblings with the same name, but nesting is much different under the regular expression limitations. This is because we can't match the opening tag with the correct closing tag when things are nested. So when you say open box, and then again open a new box inside the box you just opened, you now have two box closing tags, and they look exactly the same to naive parsers like a regular expression-based one. However, if an XML file is made with this in mind and never nests the same thing within itself, then everything will work just fine. It is then possible to create an XML parser on the command line. My Thanksgiving XML parser can be further reduced to just one long line of code. But nesting elements or tags with the same name will never work. The miniature program just grabs the first closing tag that it sees, and when things are nested like a Russian doll, that will not be the right closing tag. I woke up this morning and without thinking about my code and not really wanting to test it, I just said to myself, regular expressions, the technology I relied on, cannot match tags. And I know this from attempts at parsing XML back when XML was cool, and programmers randomly mentioned this as well. You can't use a regular expression for XML. But they may not actually know that the problem is only with nesting the same tags. If it is a well-made configuration file, regular expression parsing will absolutely work. To properly parse an XML file, you need two unique technologies, a tokenizer and a Lexer. This is how normal programming languages parse their source code. The tokenizer crawls the XML document from the first character to the last, ignoring new lines. It just sees one long string of characters. Tokenizer extracts tokens, and you have to register patterns or rules that it should recognize. XML continues being extremely self-similar, as I call it, so there are only 6 patterns, and that is a small number indeed. Because we are just eating every character in the file, we have to process spaces and new lines, and throw them away. And then there is the convenient self-closing tag. Instead of creating a closing tag, you use a / in the opening tag, telling the Lexer that it doesn't need to worry about the closing tag at all. Then there is the open tag and the close tag, and text or letters that are not enclosed in any special brackets, and finally a comment, which is very often ignored, as the case is with spaces and new lines. So you feed in the XML file as a long string of characters, and you apply each of these rules or patterns until one matches and consumes some of those characters. For example, an opening tag called button would eat 8 characters, 2 brackets, and the word button. The brackets, or the surrounding less than and greater than signs, are there to tell the tokenizer that this is an element and not some piece of text. And slowly, few characters at a time, we convert the long string into tokens, objects that have a name, type, position in raw text, and are generally very well defined. And if the process arrives at something that was not specified by a rule, then we crash fast and hard and on purpose. Because what we discovered in this context is malformed XML. Something is corrupted or wrong. This is a syntax error. Nothing that the computer can recover from. You need to go into the text file or the XML file and fix your typos and ensure that all your tags are closed. The result is a flat list of tokens, a token array. No nesting here, just a sequential list of what we matched, converted into tokens. And at this point, all the hard work is done. A tokenizer is a simple thing. It has an outer loop that just jumps past what was claimed by some token or pattern recognizer, and that inner loop where the new beginning that we just jumped to is evaluated by all the rules that we added into the system, checking for a self-closing tag, an open tag, a closed tag, a comment, etc. The resulting list of tokens is then returned to the main program. We are done with the tokenizer. It is then sent to the Lexer for what we can call lexical analysis. The Lexer converts the tidy and very flat list of tokens into elements that are actual objects that our XML text represents, and now that can be put into a tree where they are nested. Whenever an open tag is found in the list of tokens, it is added to the tree to build the resulting document up. But then it is also added to a stack, and there are multiple ways to do this. Once added to the stack, it is marked as the main parent for the elements that follow. We go as deep as possible at first through all the opening tags, building up a tree until the deepest tag we encountered first becomes a parent without any children. Then we encounter the close tag. And slowly we start making our way back out of the deepest parts of the tree, emptying the stack of all the parents, and finally having the Lexer return the now fully inflated tree. That's right. To build a tree, all you need is the instruction of open new branch, open a new branch within that branch, open new branch, open new branch. And then you may have multiple children that you're adding to a branch. That's like having multiple files in a folder. And then close, and you get out of that folder and you go up into the parent folder. And then the parent folder again. If there are some more files, yes, you can open some more tags, but eventually you added everything and you just hit those close tags and close and close and close and close. And the result is a tree. Nested elements, elements that hold other elements. That moment ago were just our tokens, only informing us of opening and closing instructions. Here, our tree, called the abstract syntax tree, is finally returned to whatever requested the parsing of an XML document, and the run is complete.